Back again with some maths guidance. This time it's on patterns and sequences. This is taken from the home learning pack that can be found on the school website and also Class Dojo. And we are looking at week 4, lesson 5, which would be Thursday's or tomorrow's lesson. Number 6, it says, here's a sequence of 3 shapes shaded on a grid. Shading the next shape in the sequence. How many squares will be shaded in the 7th shape? So to approach this problem, the first thing we need to do is we need to convert these shapes into a sequence. We want to know how many squares are going to be shaded. So what we're going to do is we're going to look at the squares that have been shaded in the first 3 shapes, and that can give us the rest of the sequence. So for the first number in our sequence, we know this is 1 because there's only 1 square shaded. For the next one, it's 3, there's 3 squares shaded, and then the next one is 1, 2, 3, 4, 5, there's 5 squares shaded. All I have done is drawn the diagram in my notebook and then written the corresponding numbers in the sequence. So we had 1 square shaded, 3 squares, and then 5 squares. Now we want to work out how many squares there are going to be in the 7th shape. So looking at the pattern here, hopefully you should be able to recognise that the difference between each is 2. So 2 squares are added each time. Now to work out the 7th number in the sequence, you could just keep adding 2 until you've worked it out. However, there is a quicker way to do this. What I've noticed are these numbers here, 1, 3 and 5. These are all odd numbers. This sequence is following the odd number sequence. So what I can do is I can work out the 7th odd number. So if I write the odd numbers down, 1, 3, 5, 7, 9, 11, 13, 15. Then all I need to do is count the 7th in the sequence. 1, 2, 3, 4, 5, 6, 7. I know that my 7th number is going to have 13 squares shaded. Now we're going to have a look at number 7. It says, here is a sequence of numbers. It continues in the same way, 6, 10, 14, 18, 22. The rule for this sequence is to add 4 to the previous number each time. Circle true or false for each of the following statements. For the second statement, it says every number in the sequence will be a multiple of 4. All I've done to start this one is I've written the sequence down in my notebook, and I want to work out whether every number in the sequence is going to be a multiple of 4. Now, a multiple of 4 means that that number is divisible by 4 equally or is in the 4 times table. This might confuse some children because we've been told we are adding 4 each time, therefore we assume each number is going to be in the 4 times table. However, if we look closer, we have started at a number 6, which we know is not in the 4 times table, because 1 times 4 is 4 and 2 times 4 is 8. We miss it completely. Therefore, not every number in the sequence is going to be in the 4 times table because we've not started at 1 times 4. So if we add 4 to 6, that's 10. We also know that 10 is not in the 4 times table. So the next statement says there will be a prime number in the sequence. Now, a prime number is a number that can only be divided by 1 and itself. So for example, 3 is a prime number because it can only be divided by 1 and 3. We know that the numbers in our sequence are all even because they end in 6, 0, 4, 8 and 2. Therefore, the numbers in our sequence are not going to be prime because they can all be divided by 2 as well as 1 and themselves. The final statement says there will never be a multiple of 7 in the sequence. Now we can have a look at the numbers that we already have. We have 6, 10, 14, 18 and 22, and we can see whether there is a multiple of 7 in any of these. Looking at these numbers here, I know for a fact that 14 is in the 7 times table because 7 times 2 is 14. Therefore, the statement there will never be a multiple of 7 in the sequence. The last question we are going to look at is number 8. It says write the missing number in the sequence below. And we've got another part of the question which says what is the rule for this sequence? Again, I've written my sequence out, 240, 120, 60, 30. Now I'm going to start off by finding the difference between each one, and then we can start to think about the rule. So the difference between 240, 120, 120 and 60, 60 and 30. So between 240 and 120, I'm going to find the difference by subtracting the smaller number from the larger. 0 take 0 is 0, 4 take 2 is 2, 2 take 1 is 1. So I found out that the difference here is 120. Now for this one, 120 and 60, we can work out the difference again using subtraction. 0 take 0 is 0, 2 take 6 we can't do, we've got to exchange from the hundreds, put it into the tens, now it becomes 12. 12 take away 6 is 6, the difference is 60. Now if you already haven't noticed the pattern, then you could do a subtraction again to work out the difference here, but I know that the difference between 30 and 60 is 30. As you can see, the difference each time, if we move down the sequence, is halving. We've halved 240 to get 120, we've halved 120 to get 60, and then we've halved 60 to get 30. So all we need to do to find the next number is halve again. So half of 30, 30 divided by 2, we'll work it out. How many groups of 2 can we get in 3? We can get 1, remainder 1. And then how many groups of 2 can we get in 10? We can get 5. So the next number in the sequence is 15. That's helped us to answer the next part of the question, was which was the rule. Do we subtract 120? Well, we can rule that one out because we don't subtract 120 each time. Double the last number. If we were doubling, our sequence would get larger, so we know that one's incorrect because our sequence gets smaller. And then finally, halve the last number. We've already worked out that we do halve the last number to get the next number in the sequence.